Hello, my name is Peter Sassman, and I'll be talking about the Native Americans and their mathematics today. So Native Americans have a very rich history. Usually when we talk about their history, we talk about their different places they lived, or their artwork, or kind of their relationship with other tribes. But what rarely is talked about is their mathematics. But it is a very interesting topic, uh, especially the geometry. Says the geometry of especially their artwork. So they had a more sophisticated counting system than kind of the ancient nomadic people. And again, in their artwork, they showed a lot of geometrical shapes. As you can see, here is a patchwork quilt by the Seminole tribe. As you can see, there's kind of many various geometric shapes, squares or trapezoids, kites, and kind of the various transformations. So just to kind of introduce the idea, most of the Native Americans' mathematics, and most of their kind of history, was based on oral teaching. So usually there's a few tribal elders, and they would pass down their knowledge to the younger members, usually through storytelling. This made them a little more kind of intimate, so they would, instead of reading a book, they would, talk to their elders. This meant there was not many written records, though. So unfortunately, when kind of settlers started coming in and kind of taking the land, many elders died, so they, from war or disease. And then when they died, it's kind of like a book getting burned. All the knowledge they possessed was lost. So we were able to, get some knowledge back, through the younger members or the still surviving members. But it's difficult, as many of the people kind of had contradictory stories or various things, various mistranslations or other such ideas. But we can see again a lot of into their artwork. There's still a lot of surviving artwork, or the style of their artwork kind of continues. So we can kind of see it at least through there, if not a writing system. So today I'm going to present kind of about the Native Americans and their counting and arithmetic, and also their geometry and some of the constructions they've used. So similar to many counting systems kind of the time, so Native Americans often had different counting systems based on kind of the human anatomy. They would have usually a one-to-one correspondence with different parts of the anatomy and with objects that they wanted to count. So for example, parts of their hands and feet, fingers, or etc. Each tribe did tend to have different counting systems, and since there's many tribes, there's a big variety of counting systems. But there was some similarities, especially in the human anatomy. So I'll just discuss a few examples now. So for example, the Zuni tribe, they used their fingers for the first 5 numbers, and then they used the second 10 on their knuckles. And then they could continue again on their next hand as well. The Yuki tribe had a base 8 system. They used the spaces in between the fingers. So kind of on each hand there'd be 4 spaces, so they had a total of 8 spaces. So they'd kind of have a base 8 system. I guess if they included the feet as well, maybe a base 8 or 16. And it's kind of similar to the traditional Inuit. They had a base 5 and kind of base 20 system. So they used both their hands and feet. So kind of all the fingers on one hand and another hand, and then all their toes as well, so kind of getting a total of 20. So again, there's a various amounts. This is just a kind of a small sample of possible ones they had. So based on these numerical systems and kind of based on the vocabulary they used, we could see that most of the tribes could do kind of basic arithmetic. So for example, addition and subtraction. Some of them could also do multiplication. And in a few rare cases, some of them could do division. So for example, many tribes formed numbers below 20 by using arithmetic operations. So for example, maybe for the number 4, they may say 1 less than the hand. Or for 7, they may say 2 more than the hand. Sometimes they also used multiplication, so maybe for the number 40, they might say, 8 hands. This is kind of similar to how some modern languages deal with larger numbers. Kind of French and German are some common examples. I think in French, the word 80, they might say 4 20s. So it's still kind of common throughout the modern language. And a few tribes, such as the Pawnee, they use division to get to smaller counting numbers of 5 and 10. Again, this was fairly rare though, so only a few tribes in North America used this system. So although they could do basic arithmetic, they could sometimes count to large numbers. So for example, they might be able to count to the hundreds or thousands, or if they had a efficient system, they could count to 100,000 or millions, maybe even a billion. Or some of the systems even had no limit. So similar to ours, we could continue counting forever. But even though they could count these large numbers, it was very seldom used. Their mathematics was very practical based. So they did not use very large numbers. They didn't have to count a million horses or anything. They had to count what they had, or what the other person had. So it was really more practical, so they didn't use these more larger numbers. So along those lines, they also didn't use much mathematics, kind of for the sake of math. They didn't sit down with various examples and try out various amounts of arithmetic. It was more, again, for just counting or make constructions, or kind of more practical. There's kind of no kind of full-on mathematicians. Again, as we mentioned before, and in geometry is more of the common area, kind of that you can see. So here are some examples of kind of the Native American baskets. So basket weaving was very common, a very common art form. So for example, on the left, we see a basket with these hexagons, and you can see the kind of there's a little tessellation and different transformations. So as before, though, they have these hexagons, but maybe it is more of just a shape. They didn't do any math with it. Maybe angles or any special properties were unknown to them. Just more of the shape. You see on the right hand side as well, this kind of step art. This is also very common throughout the kind of Native American tribes. So kind of to create these shapes through basket weaving would require kind of an intricate knowledge of these shapes and how to create them. Similar to kind of the beginning as well, this quilt by the Seminole tribe. This had a variety of shapes, and each shape the person would need to know how to create them. So they would need to know some idea of the constructions behind them. So the Native Americans had a more stronger idea of geometry than they would arithmetic. So again, it was very common in the art, but it is also common in kind of constructions. So many Native American tribes kind of settled down and had buildings, especially in the South. So, for example, the Hopi tribe or various other tribes kind of had these buildings, so they wouldn't really move around. So they often used the geometrical constructions to create bases for their structures. So, for example, some of the more basic huts could have been round. So maybe they wanted a circle base. So to get that, they would just put a post in the center of wherever they wanted for the circle, and they'd have a rope attached. They would then tie a stick to the other end, and then pull the rope taut, and they'd drag the stick around the initial post, creating a circle, and kind of dealing with the locus of points equidistant from the center. So again, they could create these basic circles, but again, it's more of a basic construction. Sometimes they also wanted to create squares. Again, in the Hopi tribe, there's many kind of square-based shapes. Kind of their buildings were kind of many prisms. So maybe they wanted to create these squares to do it. This requires a little more work than creating the basic circles. So I'll now go into detail of how they were able to create these squares. So first, they would take two sticks and put them, some distance apart. So however big they wanted the side of the square. So maybe they'd put it, maybe 10 meters or so, or depending how long they wanted the square. They would then kind of attach a rope to these two sticks. Although they could remove the rope, so it's not really attached, but they gotta stick it to it. So once they did that, they would kind of take the rope off and kind of fold the rope in half. So they'd bring the ends together. So they did this so they could get the midpoint of the rope, kind of the center of the rope. So they'd bring the two ends together and make the rope tight and get the midpoint from the other end. So then with this midpoint, they could effectively find the midpoint between these two sticks. So once they found the midpoint, they would mark it. So mark it with some smaller rope or some color or something. So in this example, you can see the red dot would be the midpoint. So now with this new rope, they would straighten it out and then put that red midpoint on one of the sticks. So for example, we'll put it on the left stick. So we'll put the midpoint on that stick, and then we're going to try our best to make this new rope perpendicular to the old rope. So for example, like this. As you can see, it's not perpendicular, so it's maybe somewhat close, maybe 85 degrees or so, but it's not perfect. So to kind of get it perfect, they would create two more ropes that tie the upper stick and the stick to the right with a rope, and then they'd also join the bottom stick and the stick to the right with a rope. So in doing this, they'd create this triangle. And then to get this, the two initial ropes perpendicular, they would want this triangle to be isosceles. So they would want those two new ropes to be equal in length. If these ropes were equal in length, then the horizontal rope that you can see now would be the isosceles triangle altitude, and the kind of vertical rope would be its base. So they'd adjust this, they'd adjust that vertical rope until those two ropes were the same length. They could do it by taking the rope off and comparing it to the other two sticks and just slowly adjusting until it's the equal length. So then they had this perpendicular line. They had these two ropes that are perpendicular. So even just to get here, they could create these isosceles triangles, And they created these knowing of the properties of isosceles triangles. They knew that this created this 90-degree angle. You know, they could have learned it just, you know, based on, you know, trial and error, you know, but they, you know, they had a concept of these different shapes. So even making this isosceles triangle, they could, you know, theoretically create other shapes. So maybe like an equilateral triangle, or they could make some of the polygons, maybe hexagons, or, you know, various other shapes. But continuing with the square, so again we have this vertical rope and the horizontal rope that are the same length, and they're at 90 degrees, with the horizontal rope being right at the midpoint of the vertical rope. So they would take this process and do it one more time to the stick on the right. So after doing this again, now they had these two ropes that were parallel to each other, and they were both the same length, and again the distance between them was the same length as the rope themselves. So now all they had to do is create a rope between the top two sticks and the bottom two sticks. And now we would have the square would have all four sides the same length, and the two corners, well, I guess all four corners would be 90 degrees. So through these constructions, we'd have created this square. So again, it's a little less pure mathematical. You know, when we did in maybe junior high school, we had constructions with compasses and you know, straight edges, and we did that to get more exact. Well, this one, especially the isosceles triangle, was a little more trial and error. You know, they would create these side lengths until it matched. But no, nevertheless, they'd create this square. So again, they would have to know these basic properties of the square to be able to create these. But again, this was more practical based. They wanted to create maybe a square based building or a circle based building, or, you know, maybe put into some art. But there wasn't really any evidence that they considered these constructions kind of mathematically. They did sit down and, you know, maybe, okay, what new shapes can I create, and how can I create them exactly, and, you know, ideas like that. It was more, you know, I want to create this square for the building. How can I do that? And then, you know, it's taught down from the tribal elders. So that's all for my presentation. Here is my references. These were mostly the same references that we did in class, as well as a few other ones. If you're interested at all in this kind of artwork or these constructions, I recommend kind of reading through some of these other ones. I think it's a very kind of interesting topic, and especially if you're, you know, interested in art, it's a good connection. It's also a very good connection for your students, so maybe your junior high school students or high school students, if you want to kind of relate culture and, you know, culture to kind of mathematics or artwork. You know, if the students are a little low in math, or they prefer kind of more of the geometrical shapes than the algebra and calculations. So it's a great way to kind of help the students and, you know, spread a little cultural knowledge to them as well. So thank you for listening. That's all.